Okay, this is recording 1C where we're going to look at graphing and solving absolute value equations. Again, just using one variable. So the main objectives here is one, can we solve absolute value and basically come up with the two different answers that come with it. And then can we graph it on a number line. So that's the two major objectives for today. So let's take a look here at what absolute value is. Now, absolute value is considered a distance. So if I ask the question, how far do you live away from school? You may say, well, I live 4 blocks away from school. And another student may say they live 4 blocks as well. But they may live in different directions. So direction is not important with absolute value. So if I'm going east or west, like positive and negative on a number line, it doesn't matter. It's the question of how far is the distance from point 0 to that value. So if we look at this and say, what is the absolute value of 5? The question is really asking, how far is 5 away from 0? So the absolute value of 5 is 5. The absolute value of negative 5 is also 5. Both 5 and negative 5 are both 5 units away from 0. So there's always a positive and negative aspect to absolute value. Absolute value is a distance and doesn't have any sign attached with it. So the default is typically always understood to be positive because we're talking about a distance. So when you look at equations we have to solve, you say, okay, one is x, the absolute value of x equals 7. What numbers are 7 units away from 0? Well, there's two answers. There's positive 7 and negative 7. Both are 7 units away from 0. So whenever you solve these problems, you have to look at both the positive and negative. So let's take a look at some examples that show that. Okay, so here's an example where we have an absolute value equal to 7. Okay, now the key for all these things is to get the absolute value. Notice the quantity inside the parallel bars here, and set that equal to both the positive and negative. So notice we split into two equations, a positive equation and negative equation. So basically saying, one is this quantity equal positive 7, and one is this quantity equal negative 7. So notice I take out the absolute value bars and set equal to positive 7 over here, and over here, negative 7. And you basically solve this two different answers, and you get 5 and negative 2. So for both answers, you'll get a distance that is 7 units away from 0. So let's plug 5 in. 2 times 5 is 10, minus 3 is 7. 7 is 7 units away from 0. Plug in negative 2. 2 times negative 2 is negative 4. Minus 3 more is negative 7. Negative 7 is also 7 units away from 0. So both answers work. So the key here is once you get the absolute value isolated, split it up. So let's take a look at an example where you have to do some work before you do the plus and the negative. Now notice, here we have 2 times googly moogly, which is the absolute value, plus 3 equals 17. Before we can do the positive negative split, we have to isolate the absolute value. So the first thing we have to do is move to 3. So we subtract it over and get 14. And then we divide by 2, because 2 times a quantity, which is the unknown, the variables inside that unknown, equals 14. So get rid of the 2, undo multiplication, and you divide. So now that we have x plus 4 absolute value, now the absolute value is isolated. Now you can split it, positive and negative. Okay, can't stress it enough. You can't dig into the absolute value until everything else is cleaned up on the outside. It's very much like working with parentheses. Okay, you have to do the right order here. So once you do that, we have positive 3 and negative 11. Again, whenever you do these type of equations, I always like to check your work. So plug them back into the original equation and make sure they both come out to 17. Okay. Now let's take a look at the number line. So here we're talking about a range of answers, much like the inequalities that we looked at the other day. So one is the absolute value of a number less than 5. Give me numbers that are 5 or closer to 0. So that would be 5, 4, 3, 2, 1, all the way to 0, and obviously all fractions and decimals in between, both positive and negative of the absolute of the 0. Okay. So here we're talking about a range of answers, very similar to the and or. And in class we'll talk about how to recognize that. But for right now I just want to talk about how we set up these equations. So again, isolate the absolute value. One is the absolute value further away than 8 or equal to 8. So notice equal to means we include that 8 value. So again, you do the positive and negative. So you simply strip away the absolute value, say greater than or equal to 8. Now notice, on the negative side, whenever you introduce a negative into the equation, you're taking the opposite value. So with inequalities, like we learned, you have to switch the sign. So notice the sign here is now less than. Okay, so that's a really big key here on these problems. Once you split it, once you introduce that negative, you have to switch the sign. And then obviously you solve them both independently, and we get two values when numbers are less than -4 or positive than 4/3 over here. Okay, notice it looks like an OR graph where the two sets of answers repel each other. All right, let's take a look here again. So this is kind of tying the two concepts together. Notice we have to isolate the absolute value first, so we're going to move the 3 to the other side and get 20. Then we got to get rid of the 4, so we divide it out, and now we have an absolute value that is less than 5. So here, now the absolute value is isolated, we're going to split it into positive, negative. Since it's an inequality, when I introduce a negative, I switch the sign on the negative side here, and I solve and I solve, and I have x values that are less than 4 and x values that are bigger than -1. So we have an overlap situation. Notice x values that are less than 4 but also greater than -1. So this is much like an AND statement in between. Okay, and again, in class we'll talk about how to recognize that. Is it AND or looking at the absolute value initially, and it's a good way to kind of check to make sure your work's in the right direction. Okay. All right, now here we have two problems. I want you to try these two problems before you come to class when we talk about this. Again, both absolute values. Notice when we're solving for two set answers, and here we're looking for a set of answers, either an AND or an OR statement. So again, I want you to try these, and we'll review these at the beginning of our next class when we do review absolute value.